Hi everyone, I'm Vinayak here and I welcome you all for this webinar. Today we are going to talk about overview of HCL Sametime Premium Meetings 11.5, followed by most common troubleshooting tips. This webinar is hosted by HCL Software Digital Solutions Organization. Next slide, please. Okay, so let me introduce the team. I'm the facilitator, Vinayak, and with me I have Tony Payne, a senior member of our dev team, and Rajiv Manna from our support team as our speakers. We also have today our panel members, Trevor Alexson, Cassie Toole, and Ranjit Rai. Please note, this session is being recorded and all our participants would be on mute throughout the session. For any questions, clarifications, please feel free to post them on the chat section and our panel members would be happy to respond to them. Today's presentation has also been uploaded for everyone's reference in the handout section. Once again, a warm welcome to all of you. And now I would be handing it over to Rajiv. Over to you, Rajiv.
Thanks, Vinayak. So before I start with the agenda, let me tell you this particular session, basically it is a continuation session of the earlier session which we conducted on 10th of December and delivered by Tony Payne. So in that session, we mainly talked about the different HCL Sametime deployment strategies. In this particular session, we will be talking more about troubleshooting. So here is the agenda for today. So we will have a quick overview of HCL Sametime Premium features. Then we will deep dive into troubleshooting, followed by a question answer session. Next slide, please. So in the HCL Sametime Premium feature, the most common feature are like within the core feature, we have one-click video meeting. That means if you hit a meeting server URL from the browser, even if you are a guest user or an authenticated user, you can directly go inside the meeting, right? So the key thing here is that from the browser side, there is no plugins needs to be installed. The persistent chat feature has been there in our product HCL Sametime 11.0, but there has been a lot of improvement we made in the latest 11.5. Broadcast capability, one can broadcast his meeting to the YouTube mobile app. Right now we have a single mobile app with which one can it serve both chat and meeting. There are a lot of controls has been introduced with which it improved the meeting experience. Some of the presenter controls are mute all participant at once, stop all video at once. Meeting room ownership. So once you start a meeting, as a meeting room owner, you can decide to whom you can make presenter, to whom to make him as a moderator. As a meeting room owner, you can decide whether guest user can join in or not. As a meeting room owner, you can decide whether you can mute, you need to mute all the participants or not. So as a meeting room owner, you have absolute control of the meeting room. One can secure his meeting by implementing password protected meeting, at the same time by using the lock meeting feature, so that no unwanted guest user can join in. Next slide, please. So the idea here is that we made the HCL Sametime meeting simple for end user. It is a single offering for both chat and meeting. It based on modern technology such as WebRTC. So in a single place, one can do video, audio, and screen sharing. Again, the key thing here is that there is no need of plugin installation from the browser side. No configuration is needed. So you just hit the meeting URL, you are in. From the administrator point of view, if you compare our HCL Sametime 901, the complexity has been greatly reduced in the HCL Sametime meeting 11.5. Now you can deploy the product, if not minute, in hour. You need fewer server. So overall, lowering the total cost of ownership. Next slide, please. So key idea here is that the persistent chat has been integrated within the meeting. So that means, like, you join a meeting and you are doing a chat within the meeting, and whatever conversation that is going on within the meeting, if you are logged in during that time, either in your rich client or web client or mobile client, then that conversation will go to those uh, chat client. So even if you ended the meeting, that conversation you can carry on those client, and you can even invite somebody who did not get a chance to join the meeting, and that person can continue the conversation. So the key idea here is that you can continue the conversation as long as you want. Next slide, please. So this is our HCL Sametime mobile app 11.5. So it has been built from the scratch in a single app. We serve both chat and meeting functionality. It has extensive language support. It supports full iOS emoticons. It supports persistent chat, multi-device support. That means, suppose you are working on a desktop client and you are switching to mobile client or vice versa, the conversation follows you. You will not lose any conversation. Next slide, please. So broadcasting or live streaming, this is a new feature of HCL Sametime Meeting 11.5. So one of the use case would be like that, when you have a many user are there who want to attend the meeting, but there is no need of two-way communication. In that kind of scenario, you can think about broadcast your meeting to the YouTube. So if then in that case, user will be joining on the YouTube, they will having the experience of watching the meeting as a YouTube live stream. Next slide, please. So this is where we start with the troubleshooting. So I would like to ask Tony to take care from here. Over to you, Tony.
Hi, thanks, Rajiv. So we're going to start off talking about troubleshooting by going over the topology and the network requirements for our meeting server and the way it fits within the community and chat environment. We'll spend a little bit of time talking about the requirements or the troubleshooting, how we talk to MongoDB, what we need on the community side and the proxy server, but we're going to spend the majority of the time talking about troubleshooting and understanding the way the new meeting server works. It's quite a jump from the prior world of Sametime v9, where you had multiple servers and a lot of WebSphere things you needed to know, and you had a server that was strictly meetings and a server that was strictly audio video. You might have had another one for a video bridge called the MCU, and now it's really one server with multiple components running under either Docker or Kubernetes. And the way we approach that and the way we troubleshoot that and get the information we need is a little different. So let's spend a few minutes talking about the topology. In the standard chat-only deployment, which is what I'm assuming that most of you are already familiar with, we had a community server, which was, of course, the main component of the environment. It's where all the real work goes on, and that is where our rich clients connect to over 1533. Support it always has. To that, we would add a Sametime proxy, which is used for mobile and browser support. So all the browsers and all the mobile clients connect to the Sametime proxy over the SSL port 443. The Sametime proxy then literally proxies those connections back to the community server over an internal port of 1516. Both the proxy server and the community server talk to MongoDB. Proxy does that for our mobile clients. The community server does that for our persistent chat feature. All of the chats that are going on, all the conversations that are happening at a given time are stored in MongoDB, so that when another client logs in or when you come in later for history, that information is pulled from there. And then the community server also talks back to LDAP if you're configured for that, for its directory infrastructure. So, that's where your user lists are stored. Now, so this is the same as it has been for a very long time, but when we add the meeting server to it, we really are not adding that much. We're adding quite a bit of features, but we're only adding one host, or I want to call it a box. It's an entry point, right? If it's Docker, everything is on this particular machine. If it's Kubernetes, it may be spread over, but to the end users and to our connectivity, it looks as if it's one thing. So it will talk to the community server or to the community through the Sametime proxy. So all authentication and that persistent chat that you saw within the meeting all comes from the Sametime proxy. The Sametime meeting server will also talk to the Mongo database. That is where our meeting room information is stored. So everybody, when they first log in, is given a default meet me type URL. They don't have to do anything for that, and it will be available for them in the client and when they log into the meeting server. If you want to reserve a meeting room name, say you've got a staff meeting, or Bob's staff meeting or something like that, then you want that name to be reserved for a specific meeting. As an authenticated user, you can create that, and that information is also stored on Mongo. Now, talking about Mongo a little bit, while we show here in this diagram both the community and the meeting server pointing to a single MongoDB instance, that's the way we think most customers will deploy it, but it's not required. If for some reason you need to move the meetings database to its own instance of Mongo based on where it's deployed in your network or some other requirement, that's fine. It's just important to note that the meeting server now does require access to a Mongo data source. You'll note here that the meeting server does not talk to LDAP. Again, as I mentioned a moment ago, it gets all of its authentication and authorization information from the proxy. So when a browser joins a meeting and logs into the meeting server over TLS, over 443, that authentication information is proxied to the proxy server over TLS again, and that's where it will be handled and then be sent back. From a meeting audio and video stream perspective, all of that information to the browsers is sent over UDP ports, 10,000 for the Docker, 30,000 for Kubernetes, and that's the only two ports you need to open to the meeting server from your clients. And that's makes it much simpler than it used to be. We used to have to deal with SIP and a few other things. So it's very simple to deploy this and to get it working through your firewall. The final connectivity we want to talk about a little bit here is to Stun. And I have a slide, a couple of slides after this that go into a little more detail on Stun. But just be aware that by default, the meeting server is configured to use the Google public Stun servers, which currently use a port of 19302 UDP. Now that is configurable, and we do have documentation on how to change that to a different Stun server if you choose, or if you're in an entirely internal environment where you might not need Stun, how to disable it. But do keep in mind that out of the box, we do have this requirement to get there, and it's very important that you're able to. So just to put some words into all that I just said a moment ago, from a meeting standpoint, clients use 443 HTTPS to access the meeting center. This is where they will log in. This is where they will get their list of meetings that they own. This is where they would create a dynamic meeting room if they chose to, or just join a meeting. Clients also then, once they're joining the meeting, they're given a URL to a specific meeting room. use, of course, 443, but they also then use the UDP ports of 30,000 for Kubernetes or 10,000 for Docker. And that's what the media streams will go over. Now, keep in mind, this is the inbound port to the Docker or the Kubernetes container. The outbound port back to the clients is dynamic based on the client. It's an ephemeral port. Most firewalls allow for this pinhole type of communication, but just keep in mind that the only one you open to your server is 10 and 30. Outbound back to the clients will be determined by the client itself and is dynamic. And then finally, again, just to reiterate that the clients and the servers both reach out to the stun servers to negotiate IP addresses as needed. So let's talk about what stun is. Stun is a utility. It is a standardized set of methods that stands for Session Traversal Utilities for NAT. And what this is you have a service or a stun server that is in a central location. It's away from your meeting server, and it's away from your clients. And the idea is that the clients and the servers will reach out to this to determine what its true public IP address is according to that reference point. So, for example, in today's world, I'm sitting behind my internet provider's cable modem. What my local machine's IP address is would have no routing capability to the outside world. It's all going to be dependent upon the IP address that's assigned at that other router. Similarly, a meeting server, the Docker container or the Kubernetes environment that's launched that meeting server, the video bridge portion of it, the IP address that's assigned internally is not going to be a routable IP address. So we reach out to stun because we've had to traverse the network to get to the stun server to determine what IP address as I would be seen on the real world. And then that IP address is where my clients will attempt to connect to and where the meeting server will know to send data back to. Now, that sounds real complicated, but it's not. Everybody understands what is my IP address services on the browsers, on the web. It's the same type of service. It's just determining the IP address that you are really advertising. And the meeting server locally isn't necessarily going to know that. Now, if everyone on the call is within the same network, if everybody in my house wanted to join this call, I could advertise an internal IP address, and I don't need stun for that because we're never going to go outside this particular network, and I'm not going to bring people in from outside the network. In that case, you could disable stun. But again, as I said a moment ago, in today's world and in today's working structure, most of the time stun is needed. You're not locked to the Google public stun servers. They're free, they're available, they're worldwide. So that's why we chose them as a default, but you're not locked there. There are public open source servers, there are other public utilities that you can hit, and those can be configured if desired. Just keep in mind that once you've configured stun, wherever you're pointing to must be available to your clients and to your server. And finally, we're not using this for a relay, which in the V9 days was called turn, which is traversal using relay NAT. What that did was allowed for this central server to not only act as a IP address negotiator, but to also fall back to where the media streams could go through it before it got to your media infrastructure. We're not doing that with this release of the meeting server, which means that none of the media stream data is going through another device. It's all direct. So we're not sending anything to the public stun servers other than a request to find out an IP address. So no media data is flowing through there, so there's no real security implications there. So when we dive into troubleshooting a little bit, we have to make sure that all of our environment is working as individual components first before we try to do a meeting, because meetings depends upon the community depends upon Mongo, the community depends upon an active connection to LDAP or to your directory, and things like that. So if we're having trouble, I always like to start at the basics and make sure things are working. If I need information from the community server, the easiest way to get that and to provide to us here in support is to run what we call the stdiag zip. That particular utility will collect all of the trace files, all of the configuration information we need, and zip that up and give you a file that you would send to us. If tracing is needed, there is instructions in our documentation about what levels to set. You'll probably have heard by now a particular command called VP trace all. That one is the simplest and will get us all the information we generally need. A Sametime MUX server is an optional component which allows you to separate the 1533 connection from the back-end community server. If you happen to be running one of those, the only things we need off of it is the trace directory itself and a Sametime INI. It's a much simplified, simpler component as far as the number of things to gather. The proxy server, which is running on Tomcat, there's two key folders that we like to get. One is the config folder so that we can see so we can see the configuration, and secondly, the logs directory. That will have all the information that we generally need to troubleshoot things. Now, again, when you're setting up meetings, because we depend upon the chat or the community infrastructure, always test that first. Make sure that a rich client can log in successfully and that you're getting persistent chat there. Make sure that a web client can log in and gets persistent chat and that everything's working correctly. That will greatly simplify the troubleshooting steps as needed when we get to the meeting server side. So we start there and then we build on it. Now, for the rich clients, that's the installed clients. If we need data from them, there's a help support, collect support data menu item, and then that will create a zip file that you can send to us in support. The mobile and web clients, we usually like to get what's called a HAR file or a fiddler trace from the browser. Those will give us all the information about the request and response cycles that are going on with the server, give us errors, or give us whatever data we might need. And similarly, the mobile client has its own logs that you can get from its menus and send to us. For MongoDB, the primary issue we ever have with Mongo is dealing with the replica set configuration. And that's because the host name that you connect to the MongoDB server, when you've configured it for a replica set, which we do, that MongoDB server may redirect you to a different host name than what you expected. And that's because when you create that replica set, MongoDB will create what it thinks its own local host name is for that instance. So what we like to get when we are debugging for anything on Mongo, if we're having a persistent chat problem or, well, basically just a persistent chat problem, would be a screenshot of the MongoDB shell. That's just where you type the word Mongo and a command screen shows up, because that first screen will give us a lot of details about the local config. One, if you're able to connect to it, that's the obvious thing. The other thing is whether or not the replica set is working. And then we can get the results of the RS configuration, and that will tell us what host name that Mongo will be returning to the client. And so we'll want that screenshots, and then we will also likely want the MongoDB configuration file and the MongoDB logs directory if we get to that point. Most of the problems that are related with MongoDB are all about getting the replica set's host name correct or the expected value. So let's dive straight into the 11.5, the meetings troubleshooting itself. So the primary installation issue around Docker, Kubernetes is different, right? We kind of expect that you, from a Kubernetes standpoint, are very familiar with where you're going to deploy it, right? Kubernetes is a large piece of the puzzle, and we expect that you are familiar with that. So installing a Kubernetes is very simple, and you don't run into the types of troubles that you do with Docker, because Docker is very simple, and you don't have to have a lot of experience with Docker, and many customers start with Docker. So The common issues around the Docker part is making sure that you have the correct version of Docker installed. CentOS, for example, ships with Docker installed, but not necessarily the version we need. So you can use the command Docker version to confirm what version is there, or follow our steps in the documentation that talk about removing whatever might be there and running the new yum install command such that you get the latest version of Docker and you know you have the latest. The next most common problem on Docker deals with the Docker compose command, whether or not you have permission to actually run literally the command called Docker compose, or whether or not you're in the correct folder. So everything you do with Docker is relative to where you have unzipped the Sametime meeting server installation files. There's a Docker compose.yml file that we'll talk about more in a moment, but that file tells Docker compose about the environment and what to do. So where you run the Docker compose command from has to be relative to that, and make sure that it's there. The two common problems here around permissions is whether or not you're running as root, or if you have a user with appropriate sudo access. If you're using a sudo user, make sure you preface the commands with sudo. And then finally, for this slide, if for some reason the installation fails, or I've decided that I don't like my config and I want to start over, all you have to do is delete the Jitsi config directory before you attempt another install. Nothing else is going to change. What happens with that installation is that we tell Docker about the images to load, and then we create the Jitsi config folder with the configuration from the files, the 3 key files. So continuing on talking about Docker. So there are 3 key files that we use. The Docker compose YAML file, which tells Docker and the Docker compose command about the different components and how to have them start up. This file has, sometimes we will have you edit it to add things like the extra hosts if you're having some DNS issues. But for the most part, the Docker compose YAML is a file that you should not ever need to touch. Just keep in mind that when you run your commands, you're going to be running them relative to where that file is. The .env file is all the environment variables that the meeting server needs to start up properly. It has quite a bit of our configuration settings that are modifiable. The env file, though, is again not one that we expect you to ever have to manually edit unless you have a very specific customization or need. The custom.env is the environment variables that you do sometimes need to edit. This file contains pointers to the proxy server, to the MongoDB server, and things of that nature, things that are very different for each deployment. Now, our install script will create that file with the things that you tell it during install, but if for some reason you need to update it, that's the file that you'll probably touch the most. Now, the Jitsi config folder is generated when you run Docker compose up, and it is generated based on the values in custom env and .env. There are other settings within that folder that sometimes, for some special customization, like needing to deploy your own SSL certificates, where you may get into that folder and make a change. Be very careful if you do so. And then also keep in mind that if you make a change in that folder and then need to modify the config later, you will need to re-implement whatever change that was. Again, the most common one will be around the TLS settings for your certificates. Some common commands for Docker are Docker images and Docker PS. This will tell me what images you have loaded in that particular Docker container. And the PS will tell me what their running state is. If I need to get logs from a specific component, which happens quite often in our debug, things that we'll do is we will type in the command Docker compose logs. We will get the component name. If you're talking with us, will tell you, but you can get the component names from the Docker images or from looking at the Docker compose YAML file. The most easy way to look at those logs is to pipe them to a text file. And it's just a Linux command with a little caret there to the right. And then that file will be created relative to where you've run the command from. And then you can take that file and look at it in Notepad or Notepad++, and you can analyze what's going on. There are times when you need to get into the shell of a particular Docker container. If you're not familiar with Docker, when you're running Docker, each one of these components is running inside its own little environment. And sometimes you need to access that environment to do things like get a TCP dump or run ncat or some other command to see how it's functioning, you know, from a network perspective. That's the most common reason. And you would do that by running this docker compose exec, again, passing in the component name of the one you want to access, /bin/shell. Now, all that being said, and I know I've covered quite a bit there, if I've made a change in my .env or my custom.env files and I need to restart the components and make sure that my configuration changes are met, the steps are quite simple. Docker compose down, that brings down the meeting server and all the components with it. You would then delete the Jitsi config folder, and then you would do a Docker compose up-D, and that will redeploy the components, re-energize or regenerate the Jitsi config folder based on the current configuration. Very, very simple. This is a screenshot just to kind of give you an idea of what a Docker images command will return. This would tell me all of my different components like Jibri and Web and JVB and Jagasi, the persistence node. It will tell me when these components were built. This particular image came from a pre-release or a candidate that is based on the October 28th. That will tell me as a support analyst which particular build of a component you're running. The ID here is just an internal mapping, an internal GUID. It doesn't mean a lot to us, but it's there for our use and tells us how long ago or how long it's been running for, and the current size on the disk. For Kubernetes, the concept is still the same. What changes is the command I use. Now, this is well after the installation or the deployment on a Kubernetes environment, which again is very simple in that you're running an install script, which literally asks you the questions you need to answer and then deploys it out into your environment. Now, later in the helpful links section, we have a link to the document, but we have published now an AWS guide to deploying in Kubernetes in the AWS Kubernetes environment. We will be publishing a similar one to the Google environment, which is a step-by-step walkthrough on that deployment. But once I have it deployed and I need to get information about it, this is how I will do it. kubectl is the way I say it, but kubectl is simply Kubernetes control. It's analogous to the Docker compose file, which is how I ask the container for information about the images it's running. kubectl space get space PO shows me all of the pod names, all of the pieces that are running in that environment. Then if I need logs from one of them, I will run a kubectl logs and then pass in that PO name. It's a little different compared to Docker, because Docker, you just maybe will do like space JVB. For the PO name, it's JVB with an identifier on it. So it's different in the way you pass that particular piece, but pretty much the same idea. And then just like being able to pipe the logs to a file, I can also run other commands in Linux, like a grep command. And this particular sample command with the deploy space / video grep discover is how I might determine what the stun address was that was returned, the public IP address that was returned to my stun request. And then a really handy thing for Kubernetes is the kubectl describe command, which gives me basically a one-page analysis of the particular piece and its current running state. straight reading that file or straight reading that output can tell me if I'm having a CPU utilization problem, I don't have enough resources, I can't access something, it's waiting on on another resource that's running. So if you see in kubectl get PO that a particular thing isn't running well, sometimes kubectl describe on that PO name will give me all the information I need to solve that problem. Now, similar to the Docker, if I need to restart the meeting, all the meeting components and apply configuration changes, I will do this with a couple of Helm commands. Helm is another utility that is used with Kubernetes that basically deploys and configures the individual components. So kubectl is a way to control the components. Helm is a way to modify the components. To stop all of the meeting server components, I would do a Helm uninstall Sametime meetings. Don't let the word uninstall frighten you. It's not uninstalling it like a installation program. It's simply stopping them and bringing them down. And then I would do a Helm install Sametime meetings and then that will bring it back up and regenerate all the appropriate configurations. And that dot is important. It is not a typo in these commands. That dot is saying I'm running this in the local directory, and that local directory that we're expecting this command to be run from is where the values.yaml file is from the instructions. That's the file that you might modify the most. So you're going to run this command from that location, and if you're not running it from that location, then you would replace the dot with the path to that location such that it can find that values YAML. So let's get a little more specific. That's the big picture. Now let's be specific about some common problems that we run into and how to help. So the first one is, the user hits the meeting front page and they try to log in and they get the oops message. Oops, something's happened, contact your administrator. Remember that all authentication at this point, this is nothing but an authentication request. All that authentication goes through the community server via the Sametime proxy. So the very first thing we're going to check is to make sure that the meeting server can resolve and access the proxy server. And if those work, you get to your proxy server and you look at the logs, you see the request came in and there's an error in the response, right? The community server, nope, says can't log you in. Whatever that error is, we will trace that through the proxy and community server, just like any other authentication issue. If we're gathering logs to send to support, we're going to want the NGINX and auth logs. Those refer to the components under Docker or Kubernetes. We're going to ask for the proxy and community stdiag zips with the tracing enabled and a file called stproxyconfig. Again, that's part of that configuration folder so that we can see the config. And then probably a HAR file from the browser, because there will be clues in that HAR file, like whether or not you've used fully qualified host names, whether or not we're having a cookie collision problem or things of that nature. And a HAR file or a Fiddler file will help us see that. The most common problems are very simple, that the meeting server cannot get to the Sametime proxy server at all. It either can't resolve the host name or if port's blocked on the firewall. It gets to the wrong Sametime proxy. You're reusing an alias, and that particular time, the alias pointed to a different version of the proxy server that wasn't configured properly or wasn't expecting the requests. JWT configuration issues, meaning that there's a manual step to copy and create the secrets from the meeting server over to the configuration of the community and the proxy server. A typo will hurt that. And of course, so that's something to check. And then finally, the policy configuration itself for IM meetings enabled, another manual step that we want to make sure that is accomplished. Once we get authenticated, the next thing we want to be able to do is create our own custom meeting rooms, or we're not getting the list of meeting rooms back on that home page. The most common issue there is related to the meeting server being able to access MongoDB. And I bring this up really specifically for this page because this wasn't required in the pre-release. So if you've been reusing the pre-release and you're updating to the new one, this is a new requirement that stumbles a few people. So let's just make sure it's there. You can, like I said before, you can reuse your existing community-based Mongo server, or you can create one that's specific to meeting. That's entirely up to you. We have to be able to get to it regardless of which method you choose. The must gather is the catalog logs from the component. And then the most common problems are related to can't reach it. Either my authentication, the username password that I'm passing to Mongo doesn't have access to my database, or the replica set configuration is returning a host name or IP address that's different than the connected one that we initially passed it. As I said before, MongoDB will sometimes, especially on Linux, will put in a local host address in that particular configuration. And of course, that's never resolvable to a different machine. So that's something to check. So I've authenticated, I'm able to create rooms, I can get to my rooms. Then the next thing I do is I try to join a room. And this is our next, you know, as you go down the path, this is the next most common problem. And that's where I get stuck on loading. I can't join the meeting. The little rainbow bar kind of goes back and forth and you're just sitting there waiting. This is where stun, or my Docker host address, and my public IP address of the meeting server all come into play. So the first portions are all web and browser based. Now at this page, now we're doing real work to the media streams. So stun connectivity is very important. We're going to look at the JVB logs to make sure that I'm able, if I'm configured for stun, that I'm able to reach that stun server and come back with an appropriate public IP address that the clients can reach. So if we're connected to stun, then we make sure that public IP address is what we expect. If we're not connecting to stun, we fix our connection to stun and then check the public IP. If for some reason I have set a Docker host address is set in the custom.env file and is an optional setting. Most of the time we want it left empty. If it's left empty, then the stun connectivity is used. If it is set, then whatever I have set it to is what will be used as the public IP address that the clients will attempt to connect to. So it needs to be a routable IP address. The odd thing here is that if you have disabled stun and you have not set the Docker host address, then the Docker's container IP address, which is an internal IP address to Docker, will be advertised and clients won't be able to connect that. So all of those things work together to establish the client connectivity, and we need to validate that they are correctly set. I have here in the must gather the catalog logs, because what can happen if we didn't check the slide before for creating a meeting room, if we're not able to get the catalog to check the room settings, then that can cause the same type of loading issue. So I think I've covered all the most common problems here. Just to reiterate them: stun, your Docker host address is wrong or not set, the public IP address is not reachable for some reason, which is usually because the port 10,000 or 30,000 is blocked at the firewall, and then finally issues with MongoDB. Once I'm in a meeting successfully and I'm communicating with my other partners and I'm sure that all of my media streams are working well, the next thing that's usually tested is recording a meeting. If I can't record a meeting or I get an error back very quickly, it comes back to the same types of things to check. We always start out with checking our connectivity. You can record a meeting if you're the only person in there, but those streams at that point must be able to get to the meeting server. So we start with checking our connectivity. The most common problem, if you're successful with your meetings otherwise, is that the virtual sound driver is not installed. That is a manual step again for Docker, and it is in our install instructions, it's probably the 4th or 5th bullet item down, and it's very easy to miss during the initial setup. So that's the first thing I'll probably ask you to check. From the must-gather, we want the JVB and the Jibri logs. We always like to get a HAR file from the browsers. But again, it's going to come down to network connectivity to the server and that the server is properly configured for the recording service. So here's a couple of examples from a log file. Like, so I got installed complete, but I can't access the meeting homepage at all. I'm getting an error response. So I'm not even getting to the login part. I'm going to look at the NGINX logs, and I'm going to see if I see an error like this host not found in upstream. This means that the proxy server's host name that you gave it during the install is simply not resolvable to the Docker container. So ideally, we want those in the public DNS. Sometimes that's not possible, or I think CentOS 8 has a couple of known problems with public DNS for the Docker container. So what we do then is we would add what we call extra hosts to the Docker Compose YAML. What an extra host does in the Docker Compose YAML file is override DNS. It's creating a new host file, just like you would have at the main host for that particular instance of the Docker container, and adding in an override. And then once I've added that extra host entry at the Docker Compose YAML file, we'll do a Docker Compose down and a Docker Compose up, and then test again. Once you're able to get to the meeting login page and an oops message is received, we're going to go back to checking the things I talked about before, and that's checking the meeting policy, checking my JWT secrets, making sure you can log into the community and proxy server after making the JWT changes, and then making sure we're using a good browser. The Firefox browser was not supported in the pre-release code, is supported in the full release that we're talking about today. So make sure we're updated to the full release if you're testing things other than Chrome. Some helpful links: the 11.5 administration guide. That's our primary source of documentation. Myself and Trevor and the entire team are constantly updating it as we get hints and feedback from our customers. Please send us that feedback if you think there's a better way to word something, but always refer back to it first and start there. Make sure that you're looking at the 11.5. If you've bookmarked the pre-release, there were certainly changes between those two releases that you need to be aware of. We have the tech note here for the, as I talked about earlier, for deploying meetings on the AWS EKS Elastic Kubernetes service. That is a step-by-step article that will take you through all of the different things you need to do and has some great troubleshooting steps within it as well. We will be publishing one of those for the Google environment before long, and then maybe after that we will be able to maybe publish some hints and tips toward a on-premise Kubernetes environment. But I think you can understand that Google and AWS being the way they are, they're much more standardized, and it's harder to write a document for a customer's deployment of Kubernetes because there's going to be a lot of variations to it. But we do have those, and those guides are there to be used. We have enhancement requests if you want to have things like using only HTTPS versus UDP for the video screens. Feel free to add an idea or vote on ideas that are there. There's a link to one of the ideas to give you a starting point. We have articles based on the same ideas in Kubernetes around the host not found errors, how to add extra hosts in the Kubernetes environment. And then we have the deployment deep dive that we did on the 10th of December that I presented, that takes you through more detail on actual deployment, actual installation steps, and a little less troubleshooting. So there's that, and there's a recording available for that to refer to. And with that, I'll open the floor to any questions that we have outstanding.
Hey, Tony, Trevor here. Thanks. Very well presented as usual. We did have a number of great questions. There was a couple outstanding ones I wanted to bring up, and just if you can't answer them, we can definitely address these via support case. The first one was basically talking about setting up a single server deployment, like in a small environment, and they had a question about adding an IGNX server in front of the proxy and the meeting server. And my initial response was it should be okay for the proxy, but it may conflict with the internal meeting server. Maybe if you could elaborate better for me on how that might work.
Well, we have had a few customers that do deploy a separate IGNX proxy in front of the proxy server, in front of the meetings. The exercise of that is up to that person doing the deployment. It is certainly something that can be done, and we just have to work through making sure that everything is properly flowing through the process.
Yeah, I think the specific question I didn't ask was they would like to add it in front of the proxy for the chat, and then to the other URLs to the meeting server. And so if it was used not directly in front of the meeting server, but possibly for both, does that change our response here? Or
it doesn't change my response at all. IGNX or NGINX is just another proxy type server, okay? And we always have supported putting reverse proxies and proxies in front of the Sametime proxy, like F5 load balancers and things of that nature. What we have to do is make sure that our streams that the server doesn't stumble on our cookies, and that it knows how to keep sticky sessions and all of that alive. Like I said, I know of several customers that have deployed NGINX in front of the Sametime proxy, as well as their own in front of Sametime meetings, and we'll do our best to help support them in that. But they have to really understand the NGINX routing to make that happen.
Thanks, Tony. The other question that was outstanding was based on the internal Sametime test host. So this is kind of a two-part question. The second part about it is going into what that Sametime.test really is internally. But the question was, when we try to connect the Sametime proxy over a load balancer, but the load balancer requires a correct destination header tag host name, which in case of meeting server access is Sametime.test. Can this name be changed to another? And my immediate response was internally, no, that is a hard-coded internal connection. But in terms of load balancing and the header host name, could you comment, or do you have any feedback on that?
Yes, I can. In fact, this sounds like a ticket we had opened up this past week. If it's the same customer, I did provide an answer in that ticket. Now, Sametime.test refers to the internal network for the Docker container. When we go back to the Docker Compose YAML and our internal mapping, we have an internally namespaced network called Sametime.test. That's how component A knows to talk to component B. Within that configuration, there is a spot where we talk about setting the request host, which is what you're referring to in the second part of the question. And there is a way to override that so that it can refer correctly for this load balancing scenario. I don't have the information directly in front of me to be more specific, but if this is the case that was opened, I provided an answer in the case. Let me know if you had a problem with that. If you don't, if this is a different customer, simply open up a case and I will get that information to you until I can get it tech noted.
Excellent, thank you, Tony. There weren't any other outstanding questions, but a couple of comments I just wanted to make. One was about the documentation. As Tony mentioned, himself, myself, Casey Tooley on the call, we are working hard on making that documentation better, with the understanding that it'll never be perfect, but we're striving towards that. So please, if you have documentation comments for improvement or corrections, don't hesitate to contact us directly, or post a forum post on it, or even a case. We want the documentation to be good. There was a comment about when Domino might be replacing MongoDB, and my response is that it is being reviewed. We are working on it. We don't have an ETA at this time, but I would strongly suggest going out to the the enhancement request URL and support that idea, because I know it's already there. It is within our focus. And the last thing I want to comment on was sizing. From a support standpoint, sizing isn't in our scope, but it is an obvious question we want to help provide an answer for. So if you open up a case with sizing questions, we'll give you some good information on it, but we will then at that point direct you to our HCL technical advisor team, where they have some tools and more focus on that specific question with sizing. So reach out to HCL support any way you can, and we'll direct you to people that can help you with that sizing. And that's not a chargeable service for sizing. We're not going to direct you to a billable service. So just understand that we have the resources, and if you have issues finding those resources, contact support. We'll get you to the right people.
Right, and there's also links in the documentation. We've got a couple of pages that are Kubernetes and Docker FAQs. They do point to the links that help you get set up if you need the help with getting sizing information. Okay, well, we're at the top of the hour. If there's no other questions, thanks everyone. Have a great day.